All right. Good morning, good afternoon, good evening, good night. That's from the Truman Show. And welcome to my project two, continuity of a function. My name is Daniel Costa, and my student ID is 2254144. So let's get this started, shall we, folks? So we are going to review what was in the what do you call it, the manual for this project. We're going to discuss what is continuity of a function at xa, and we're going to do the problem solution. And the third is just going to be our reference. So, what is continuity of a function at x equals a? So, Stuart J. from 2015 says best that, quote, continuity at a point x equals a requires that the function is defined at x equals a. The limit of x approaches, well, there's a typo there. A exists, the value of the function x equals a equals this limit. To say, well, essentially, is what it's saying. It just means there's no weird jumps, holes, or breaks at that point. It's just continuous at x equals a. The function values at x equals a is what you'll expect if you smoothly move towards x equals a from either direction. So let's get into our first and only problem that we're going to solve is this problem right here. Fx over here, which is a to the power 2x minus 6a, comma, x is greater than or equal to 2, or 20, comma, which is x is less than or equal to 2. And our answers are going to be -2, comma, 5. So the first step is just to analyze the given function right here, which is first step done. Now, the second step we need to do is check the continuity at x equals a. Now we are going to use three continuities here. We need to, the function fx must be defined at x equals c. Fc exists, for example. The limit of a function at as x approaches c must exist, for example. Limit x dot dot or directional c fx exists. And the last continuity we're going to use is the value of the function at c must equal the limit as x approaches c, which is lim x pointing towards c fx equals fc. So let's check if f2 is defined. Since x equals 2, which is greater than or equal to 2, we use the first part of the function, which is f2 equals a to the power 2, parentheses 2 minus 6a will equal to 2a per hour to the power 2 minus 6a. Now we need to find the limit of x as x approaches 2 from the left. So it's like x is greater than 2. I mean, x is less than 2. So for x less than 2, fx equals 20. Therefore, lim x pointed to minus fx equals 20. Now we need to find the limit of fx as x approaches 2 from the right. In this case, x is going to be equal to or greater than 2. For x to be greater than or equal to 2, fx equals a to the power 2x minus 6a. Therefore, and it's a mouth breather, x limit x pointing to 2 positive, fx equals limit x to the pointing to 2 parentheses a to the power 2x minus 6a parentheses ended equals to 2a to the powers of 2 minus 6a. Now we shall go to step 3, which is set the limits equal to ensure the continuity at x equal 2. So for x to be continuous at x equal 2, the left-hand limit, right-hand limit, and the function value 2 must be equal. So we're going to take this little equation we got from the previous, not the previous one, I'm sorry. We're going to get this equation right here. Limit x pointing to my negative fx equals limit x pointing to positive fx equals f2. And this will give us 20 equals 2a to the power 2 minus 6a. A lot simpler to see. Now, The last step is pretty easy. We're just going to solve the equation. We're going to solve the quadratic formula to the a to the power 2 minus 6a minus 20 equals to 0. And we're going to divide the entire equation by 2, which is a power 2 minus 3a minus 10 equals to 0. And factor the quadratic equation. In this case, it's going to be closer to our answer now. A minus 5, both parentheses a multiplied by a plus 2 parentheses equals to 0. And thus the solutions are a equals minus 2 to comma 5. So this is going to be our references here. This is Stuart J. from 2015 Calculus Early Transitionals 8th edition submission. This is the link. Thank you. And the link will be provided after this video has been made. Thank you so much for listening, Professor. And I hope I get a better grade than I did last time, and I did everything right.